Hello everyone. Today we will learn how to think in AIME. I will use a question as an example and let you know what do you think when you do a question in AIME. Uh, this is the problem 9 from 2025. This is a not very hard question, but I saw some of students could not get the solution. So let's talk about this question. First, we need to read the question. The parabola with equation y is equal to x squared minus 4 is rotated 60 degrees counterclockwise around the origin. The unit point in the fourth quadrant where the original parabola and its image intersect at the y coordinate. Seems hard, so let's do it step by step. First, I draw the parabola. Okay. So this is called y is equal to x squared minus 4. And I need to rotate. So the basic idea is I need to draw it at least. 60-degree, maybe it's here. Okay. And he said that there is only one point in the fourth quadrant. Yeah, it's here. And I have the y coordinate here is a minus square root b over c, where a, b, c are positive integers. And I will write down what I have is a and b and c are positive integers. And a and c are relatively prime. What you need to do is find a plus b plus c. When I see this question, it's hard. So I will teach you how to think. Remember, here is a draft. Okay. Let's see what happened for each point, because the parabola is consists with the points. So I want to see some special points. The first specialist is here, right? Where this point go? It goes to here. Because there are 60 degrees, right? If I want to use that, so I need to find out that. So at least. Which means this is 60, right? So before, this is my y. But now this is my new y, right? This is 60 degrees. And as you can see, every point here, every point on this line, you have a symmetrical point, right? Every point, you have a symmetrical point. But where are they? How to find that? Because this triangle is very, very special, right? My blue is previous one, and my green is the new one, right? That means I need to change the blue. Green. So how to do that? I could easily find they are symmetrical with the line, this line, right? That means every point previous is here. When you do the 60-degree rotate, it is have to here. It changes to here. Changes to here. Remember, this is a little special is here we do rotate, but the rotate is the same thing as if you have a axis of a symmetry. So I find this line. So every point have a new place to go. So the important thing is this point is very special. It's on this axis of symmetry. Means that this point do not change, which means this point is on the original problem and its image. In the meantime, it is also on the axis of symmetry. Okay. If you have this analyzed, so it is easy to see. If I want to find this point, I need this line, right? This line I can see because this is a very special triangle, they are equal. So this is 30 degree. So this is 30 degree, this is 30 degree. So together this is 60 degree, right? Okay. With our knowledge on line, we know that this line, this special line is y is equal to square root negative square root 3 of x. You have several ways to do that, I told you before. Okay. So that means I have two functions. One is y is equal to negative 3 square root of s and square root of 3 of x. And one is y is equal to x squared minus 4. Together, you can get two solutions, actually. If you draw a very good picture, you will find this point is still on the line. It's also on the line. So you can draw two of them. Let's plug in. You can see this gives you that y is equal to, no, x squared minus 4 is equal to minus square 3 of x. This time, I believe that every students who took part in AIME could solve this. This time, x gives you two versions is equal to square root of 3 plus or negative 19 over 2. Because what I want is the positive x, so this is just the add. I know y coordinate is here. So this gives me y is equal to 3 minus square root of 57 over 2. So then I can write this is equal to 3 minus square root of 57 over 2, which gives you that a is equal to 3, b is equal to 57, c is equal to 2, which gives you that a plus b plus c, which is equal to 3 plus 57 plus 2, which is 62. So from the thinking, you know how to solve that. So when you're writing, you just go backward. When you do writing, you can like this. Proof. Note that the vertex of original problem and its image are symmetrically about the angle bisector. Here, the angle bisector. So the line, the equation of line, and together with we can get the solution, the intersect point is y is equal to 3 minus square root 57 over 2. By question, we know this is a minus square root b over 2, which gives us a is equal to 3, b is equal to 57, c is equal to 2. As what we learned, A plus B plus C is equal to 3 plus 57 plus 2. So the whole point of this question is you need to know if you rotate some degrees, it means there must be a symmetric line for these two image. So this is what this question tells us. And if you learn very well before, this is simple. This is simple idea, so you can get it.